gentlemen, welcome to the Good Roads Podcast. I am Jared LeMay, and filling in for Thomas this episode, Good Roads Manager of Technical Programs and Research, Dr. James Smith. How are things shaping up for the first of many, hopefully, low-volume roads workshops this fall, James?
It's coming along quite well. We've already had 40 people registered. We've had 6 exhibitors signed to come and exhibit with us, and sponsorships are nearly all sold out. So quite encouraged by the turnout. We're still flushing out the program, but it's almost complete, of which Brian's going to be one of our keynote speakers.
Fantastic. So yeah, keeping with the low volume roads theme, today's guest will be a keynote speaker at the low volume roads workshop in October 9th, right?
That's correct.
And that's in Barrie, Ontario. So Brian Keierleber, I said that right, Brian?
Close enough. It's Keierleber. and actually,
Keierleber.
I'm educated on this stuff too, and talk to people that really know the German language well. The EIE gets pronounced as a long I.
Okay, I apologize for that. So Brian is the
county. Necessary. I have fun with it. See, a name of the field that separates you from the crowd to put you on a first name basis.
There you go. So Brian is the county engineer for Buchanan County, Iowa. He's renowned for his innovative work in bridge construction and maintenance of low-volume roads, with a career spanning several decades, as he alluded to earlier with his story about the one-room schoolhouse. He's been instrumental in implementing cost-effective and sustainable engineering solutions. His contributions have significantly improved the infrastructure and safety of Buchanan County's transportation network. Welcome to the show, Brian. I'm looking forward to getting a taste of what you plan to talk about at this year's low-volume roads workshop.
Okay, well, thank you. And again, this is an honor to be invited on this. We will talk about some of this. We're going to start out with bridge repairs, because if you can repair a bridge and get some more life out of the existing ones, that's a major asset. And the prime example is we have a bunch of standards here in Iowa where they use steel beams or even concrete beams, built them back in the 1950s. They made one decision at the time that we kind of regret today. They use timber back walls and timber piling. And
right.
So now bridges built in the 50s, 60s, the timber piling are rotting out. And so one of the things we're doing, and I've got lots of pictures on this, is we're drilling holes through the timber piling, cutting out the rotten parts, and then encasing the entire thing in concrete.
Okay.
And that's a very economical solution to us. I've got a local contractor that, if I pay for the materials and the concrete, I can typically get these abutments done $15,000, $20,000 each, which is a cheap fix for a bridge. Because when you start looking at costs, it's extremely high. Yes.
Does that I'm curious. Does a repair like that, is that better, worse, or about the same than a straight up new bridge?
No, well, it's nowhere near as good as a new bridge, because the superstructure, the beams and the steel beams and the concrete beams were all designed and put together in the 1950s also, or
okay.
60s. And so they're not designed for the loads of today.
Right.
And so if you really want to start thinking, looking back on my career when I got here to Buchanan County, I had a bridge to deal with that was built in 1870, a bridge that was 1872, and a bridge that was 1875.
Wow.
And so I had some really interesting old bridges to deal with.
Yeah. A horse and buggy going over that as opposed to transports now, right?
That's right. Well, an example, the one from 1872, they moved to its current location in 1891 because it was too light. And I started asking, what were they feeding the horses that day? But it's probably more, it was kind of the age of the steam engine. And so as the steam engines were heading west, they were taking down bridges along the way. Because they were a little heavier than the horses.
Right.
So, yeah.
So I got to ask, with steam engines knocking down bridges, and these bridges being almost a century old, probably a century old now, why repair instead of replace?
Well, first of all, those bridges are all moved out. Those are all replaced.
Okay, good.
Modern structures, yes. But your question was, is it as good as a new bridge? Well, no, because it was still built to the standards of the date.
Right.
Yeah, the only thing is I solved the problem that was biting today, and that's the substructure.
Yeah.
And
Okay.
Yeah, then it goes back to width too. A lot of these old bridges are 18, 20. Well, if I'm talking those from the 1800s, they are 16 feet wide.
Wow.
And modern agriculture just can't handle a 16-foot wide bridge because a lot of the tractors now are up there. Combined with duals can be 22 feet wide.
Yeah.
And so, yeah, it's apples and oranges, but put it in perspective. I have 260 bridges that I'm responsible for.
Wow. Really?
And my average annual allocation on federal bridge funds is a little over 500,000. In other words, I get to basically do one bridge a year. That doesn't
So
work
you've got
for
to
160
no,
bridges.
you've got to find ways to save money where you can, right?
Absolutely. Other solutions so you keep, yeah. Some people
So
refer to it as kicking the can down the road, but actually the repairs that we've done, we're pretty pleased with.
Good.
to kind of put this in context, Brian had mentioned 260 bridges. There's approximately, I believe, Brian, 960 miles of road, so approximately
Right.
1,500 or so. If we're looking kind of for a comparable municipality in Ontario, we'd be looking for like the United County of Stormont, Dundas, and Glengarry in terms of kilometers and bridges for those who are listening.
Okay. Actually, I do have a quick question, and this is because I'm not near as versed in this stuff as both of you guys are.
Sure.
You mentioned you have a federal bridge fund that
Yes,
you.
I'll get allocated some. Well, it actually goes to the state.
Oh,
And in
okay.
some states, the state tends to keep the funds and not pass it on to the local
Right.
entities. In our case, we're calling them counties. And Iowa is one of the states, and then the state will quite often maintain responsibility for those bridges also.
Okay.
In Iowa, there's about 24,000 bridges in the state of Iowa,
Right.
and about 19,000 of them are in the counties. So the vast majority of the bridges are in the county level, and all the counties have a licensed engineer. So they've got licensed engineers dealing with the bridges. It's really a pretty good system as long as you can keep the state, and Iowa does a good job passing some of that funds down to you. But
Okay.
like I said, in my case, it's about enough for one bridge a year and 260 bridges. So that means we're
Well, I
dealing
mean,
with local funds
it's
and replacing bridges. Now you
yeah. I
really
mean,
start looking for economics.
it's better than nothing, though. How does that work in Ontario, James? I know, like you've done the study about the deficit in Ontario, specifically for roads and bridges. Does our federal government have help us with that at all?
Occasionally, you may find a program that will municipalities can tap into, but no. But for the large part, it's coming out of their operation and capital budgets.
Okay, wow. That yeah, that might be something that people might want to talk to the representatives about. Because I mean, that sounds like an interesting program to help out in Ontario. Here, I don't know if you've read James's information about the deficit in Ontario, but we've got I don't even know the number anymore. It's been a while, but we've got a huge deficit for backlogs of repairs for bridges and roads, and municipalities have very little help in having to repair or rebuild that stuff.
And the
So that
bridges are so expensive, and that's why we keep looking for better answers.
right.
And
So speaking of better answers, what are some of the innovative techniques and materials you've used in bridge construction? I know you mentioned about taking the wood bollards out and replacing it with concrete. Is there anything else interesting you've gotten into?
and we've done some bridges using now we're talking new construction rather than the repairs. Yeah, we've
Right.
done some fabric abutments. So we've been building bridges with our county bridge crew, which was 2 people, and we increased that up to 3 people. And then when they really need help, then we'll grab some of the blade operators and some of the other maintenance people to go help them. So the biggest one that I've been doing, and I'm up to number 34 right now, is building bridges out of retired railroad flat cars. Now, a lot of counties, and I'm one of them too, that'll take tank cars and cut the ends out of the tank cars and use them like a big culvert. So you're
Huh.
dealing with an 8, 10 foot diameter, not 10, 8 foot, 8.5 foot diameter railroad tank car that they used to carry petroleum products or whatever in. That becomes a bridge that way, a culvert. But We take the 90-foot rail cars and turn them into county bridges.
Really?
And I've got, like I said, number 34 is under construction. That's the one that's got the live link where they're setting 6 cars today. So that'll be about a 126-foot long structure, about 28 feet wide. So I'm
Okay, I got
using,
two questions about that. Number one, James, you may know this better than I did, but we did something about this in one of the last issues of GRQ, didn't we?
There
I'm pretty
was
sure.
Brian has, yes, written an article for us, kind of
Okay, I'm
on some of
gonna
these
I'm gonna
bridges.
search that up and I'm gonna put it in the show notes because if I remember correctly, that was a fascinating article. Um, and I guess onto the structural question of this. Rail cars don't seem to be terribly structurally. I don't want to say sound because obviously they are, but how did you come up with rail cars and how much weight do they support?
well, you'll have rail cars designed for different things.
Right.
But the flatbeds that I'm dealing with, I specify 80 to 100 ton car rated cars.
Okay.
So I'm saying these cars are already rated for 80 to 100 ton, and they tend to design them for point load, not the distributed load. So that
Okay.
means that the moment that they're designed for, and when people start questioning this, I say, well, stop and think. The military will put 2 M1 cars or 2 tanks,
Yeah.
M1 tank
That
on one car.
that's true.
And so that's
Okay.
only a 72-ton tank, roughly.
Only.
Yeah.
Wow, that's interesting. How did you come? Like, did you just see a train coming by one day? What was your Isaac Newton
How did
moment
that
there, where
come
the apple
about?
fell on your head? Yeah.
Okay. Well, I actually was listening to a college professor from Iowa State visiting with another county engineer from Iowa. Um, this was a lot of years ago, about 2000. So that's about 20. That was about the year it was. And they were talking about going down to Oklahoma and looking at a bridge that had been built down there. Now,
Okay.
what the true history of that is California was the one that really started the research on it in the 1960s. They were looking
Oh
for
wow.
fast ways of opening up the interstate system. And so they had started the studies in California in the 1960s. They actually used some, there's a bunch of counties out in California that were using them throughout the years. And then I, then I got extremely interested. Necessity being the mother of invention is really the whole key there. And don't ever shy away from trying new technologies or looking at new
Yeah.
technologies too. So that's what got us
Fantastic.
going the rail cars. Now I've got pictures of a bridge out in California built out of the 90-foot cars, clear span and the
Wow.
whole thing. The cars are really designed with wheels, or otherwise known as bolsters, about 68 feet apart.
Yeah.
Slightly less than that, 65 feet apart. And then the ends cantilever out. Well, they were doing the full 90-foot spans. We haven't done that yet. I've done the
Wow.
90-foot cars where I throw a pier in. The structure I've got going today, we've got a pier in there, and I'm using two 68-foot cars. So that's kind of that answer.
So, Brian, with the railcar bridges, what kind of cost savings or is it time that you're seeing the
It's money.
benefits to moving to the technology?
It's money. I'll have close to 300,000 into this structure that we're building now. Standard construction, similar construction, had I gone through contracts, would be 900,000 to 1 million.
Wow. Okay.
Yeah, that's how I can afford 34 of them.
So I got to ask too. Does the steel on those rail cars last longer than concrete? Or I guess does it
I
take more of a
suspect
hit?
they will. Yeah, and the history's not out there. You got to remember here, I was talking earlier about Bill replacing the bridge from 1870, and a
Yeah.
bridge from 1872, and a bridge from 1875. Those were wrought iron. Those are all wrought iron bridges.
Right.
And this concrete construction didn't really start until about 1900 was when they really started going with the concrete in the bridges that way structurally.
Okay.
And
Yeah. I mean, I would assume, and again, I'm not an engineer or anybody scientific at all, but I'd assume that steel built for the rails would be built outdoor safe because you want those things to last a while. You want them trucking across the country.
Sure.
Uh, and then concrete, you're left with, if it's poured improperly, if there are deficiencies in it, it's going to delaminate, it's going to crack, it's going to break. Our Gardner Expressway is a perfect example of
It goes back
something
to road.
concrete falling apart.
It goes back to road salts, and road salts are nasty
Yeah,
on anything.
yeah,
And we have a lot of them in Iowa. And
yeah.
if you get cold enough, you don't have that problem so much. But yeah,
Okay.
in other words, if you start getting in your sub-zero, when I say sub-zero, I'll even try and talk degrees centigrade. If you down in there 30 to 40 below centigrade temperatures, um, the ice that does get on the pavement tends to crack and break off.
Okay. That makes sense. Okay, so I've got to ask this too because I just thought of this. You're putting these rail cars down. What do you do for surface treatment? Because I'd assume it's not just steel.
They have metal decks on them,
Okay.
and what I do is they also got grab holes. Well, I'll lay down a frost barrier, tar paper basically,
Okay.
or Petrotac type material, and then rock across it. So I got road rock across them. Now I visited with Rob Connor, a structural professor at Purdue, and Rob's a strong believer. Brian, if you would just put shear studs on there and pour concrete decks on these, well, you'd have a bulletproof structure. And he's right. And truly, in the long run, what I'm expecting, maybe 40, 50 years down the road, that dirt contact with my steel, I may have some decks wanting to rust through. At
Okay.
that point will be a good time to clean it off and put the shear studs and the concrete on it. And my guys have said, well, why don't we do that now? And I said, why do I want to spend the money today if I can wait 40, 50 years to do it?
Yeah, and you've only got a certain amount coming from the federal government, right?
That's right. And they don't give me any of the money for these bridges. That's taking care of some of my other structures. My
uh,
big bridges on paved roads is kind of what I'm doing there. I've done a few with my own employees, 70-foot long type structures on paved roads, and that's where I partner with other private industry or whatever and build some bridges, trying to work out better ways of doing things.
Hey, Brian, with these railcar bridges, I'm also assuming you're able to put on or like build in a MASH compliant barrier system too. Is that
It wouldn't
possible?
wouldn't say it's MASH compliant. We'll put on a tri-beam rail system, and to be truly MASH, you'd have all the tests and everything go along with that.
Okay.
And yeah, it's not truly MASH compliant, but we don't have to on these low volume roads. But if I really wanted to, there's nothing to prevent me from putting on a transition zone and a terminal end section and that kind of stuff. But again, you can get a lot of money involved in that. At some point in time, there's just, hey, this here bridge is a whole lot safer than the one that was built out of timber stringers that were being overloaded on a regular basis.
awesome. Okay. All right. So let me ask you. We've talked about really old bridges, century-old bridges. Replacing those is a no-brainer. So how do you prioritize which bridges you need to repair or replace in the county?
You start looking, and then that's going to depend county by county to an extent too. So in my case, what I was doing is looking at which roads have the biggest demand on them and the
Okay.
worst structures. So you're knowing what those bridges are looking like, and you know what kind of loads are going across them, and so you try and go that way. And there's a
Okay.
few places we put in some low water crossings, and that's
Okay.
where, hey, it's just agricultural behind it, and we can make this low water crossing wide enough and long enough that the water's shallow almost all the time.
Okay. So it's really a balancing act of like how bad the bridge is versus
Demands
what
are in
its
the area. Yep.
demands are. Yeah.
If I'm on a
Okay.
paved road where I've got a lot of traffic, guess what? I'm going to go after that one a whole lot faster than one that's off on some rock road that can be bypassed by detouring around it.
That's true.
With that, or kind of following up on that, Brian, do you have any kind of guidelines that you would follow to actually close a bridge, or have you had to do that in Buchanan County?
I have a couple of them closed, and the one of them that we're replacing today with the live camera feed's been closed for about 10 years. We
Oh,
kept
wow.
pushing it back, and I'm kind of getting in the position where it's one that I can do with my own employees. If I start talking a 400 foot bridge, there's no way I can economically do that with my county crews.
Yeah.
And I've got a 420 footer coming up.
Wow.
So yeah, this 125 is going to be the longest I'll have done with county employees. It's been closed for about 10 years, but I kind of caught up on some of these smaller structures to where I can dedicate time to that. It was perfectly fine. It was only 3/4 mile around to another bridge that was built in the 1950s on a paved road.
Okay.
And that particular bridge, we've done several repairs to it. One of the more interesting is it's got the first ultra high performance concrete bridge deck overlay in the Western Hemisphere. And so we used UHPC from Lafarge and did a bridge deck overlay on it. You guys don't mind me talking brand names or names like that, do you?
No.
Because
I just
we'll get into that one a little later. We've got some other experience with ultra high performance concrete, and we couldn't find a fabricator here in the States willing to do it. And
really.
Lafarge said they do it up in their Winnipeg, Canada plant. This is about 2006. And so, yep, we had to go do beam inspection up in Winnipeg. And 4 beams, it was 4 different engineers went. I was one of them at one time, my assistant another
Wow.
time.
Cool. Okay.
Well, success breeds success too, because that was a 5-beam bridge, and you had MIT and Federal Highway and a lot of people involved with designing it, and then Lafarge built it and the beams up in the plant. I got approached about 2015 by a group from the Korean Institute of Construction Technology because they developed ultra high performance concrete, their version, and wanted to build a bridge. And so we ended up building a bridge with my county employees using the ultra high performance concrete.
Wow.
5-beam bridge patterned much after what we learned from Federal Highway's 2008 project.
So for somebody who doesn't know the difference between concrete, what's the difference between ultra high performance and regular concrete?
Now, rather, I'm going to have to talk PSI, pounds per square inch, compressive strengths. And the typical concrete that you'd use in your driveway is probably about a 3,000 pound mix.
Right.
And in our bridge decks, we typically use about a 5,000 pound mix.
Okay.
We broke cylinders at 30,000 PSI on concrete that we formed here in our yard.
Really?
And
yeah, you've got a lot more than somebody's little Chevy going over a bridge.
Yeah, well,
I get it.
Putting it in perspective, Lafarge, their patented name of their product is ductile concrete.
Okay.
And the story is they build a beam at the Turner Fairbank lab, a 70-foot long beam. When they loaded it, deflected something like 2 feet and didn't crack. And that's concrete.
Wow. Really?
And
That's
visiting with Dr. Joe Chong Ben, who was one of the professors that came over from Korea. Now, it was nice visiting with him because he'd gotten his doctorate at Purdue. So he spoke a little better English than some of them. And he says it takes 200 years for the salt to penetrate 1 inch.
Wow.
Okay, so remember our road salts are the issue with our bridge decks, and so if you can build a material that's you can expect that kind of life out of, that should be a good product.
Yeah, definitely.
But it's expensive.
So Brian, with that, the ultra high performance, increasing the cement content, but was there anything else that you did to that? Like, was there any innovative curing?
There's steel fibers involved in that. is really, it's the mix. There's no aggregates, no coarse aggregate in it. Excuse me. And part of the catch is there's no coarse aggregates with that much strength.
Okay.
How can I get 30,000 psi when my rock breaks at 12?
Yeah.
And yeah, the steel fibers are a big part of that, and that's also a big part of the cost too. So, but
Yeah.
that's not the kind of thing that you're really looking at for that. If you're, again, we were talking the rail cars for bridge, but now to get back to economics, there's a design called buried soil structures, and one of the most common comments I'll hear: "Why are you building a bridge, or why don't you just throw in a bunch of big pipes?" Well, to get the capacity, a lot of times that's not a practical answer.
Right.
How much water you got coming through there, is the issue. And so there's a design out there now called buried soil structures where it's basically half of a culvert, but they've got designed with deep corrugations and such where they can span up to about 40 feet or 60 feet. Excuse me, I've got one at
Wow.
40.
Wow.
And now they have to have a footing. Well, what I found on some of these structures, I can go in and use the old footings off of my old bridge, the old wooden piling where they rodded off, cut them off below the water line, below the ground line.
Right.
And they're as good as the day they were driven because they don't rot when they don't get any air.
Yeah, that's true.
And so I'm using those for my footings, and now I can put this buried soil structure on the top, half a culvert in essence.
Honestly, it sounds very economical
It,
down in Iowa there.
it can be. It can be in many areas.
Yeah, because I mean, yeah, like not everybody has the money to be building new bridges constantly, and I'm sure that's a problem up here in Ontario and even in Canada. Well, even across North America, is not
Yep,
everybody has the money to be building everything brand new. So, what you
that's
find savings where you can without sacrificing quality, because you don't want one of these bridges to collapse.
no, that's the name of the game.
Yeah.
So, Brian, I believe if I understand your network correctly, of the 260 or so bridges, you only have two or three of those buried soil structures. Are there more planned for the future, or is it also kind of a constraint of the space that you need to put that in compared to another
Just
type of bridge?
just like the buried soil structures, it goes back to I have something that fits right in that environment. That's really what that amounts to. And so, in answer to your question, I'd have to add them up, but yeah, got 3 or 6 of them. I don't remember right now, even. And yeah, there'll be more places come along for them. If I need something 60 feet long, then I'll put it in the rail cars. If I need something 20, 30, 40 foot, it's either the buried soil structures or maybe precast slabs, or we're working on some other designs too. And
Nice.
there's another design that I'm real optimistic on, and that's that because again, if you can, the world has changed. In the 1950s, labor was cheap and materials were expensive.
Yeah.
Nowadays, your labor costs are a significant issue to where you look for designs that reduce the labor requirements. And um, prime example is the grade 65 steel. And I built a bridge that way, but I put a concrete deck on it. And I really was wishing I'd put some of the other metal decks on. But there's work now on orthotropic bridge decks that could be extremely practical where to build a bridge, you could do your stub abutments like we're doing, or if your environment's right, use the fabric of bridge abutments. And I've got a half a dozen of them.
Mhm.
And um, then set the beams, steel beams on it, and a metal deck. That might be very economical answer. But the goal is to find an economical way of doing this stuff.
Right.
Stretch the
But
dollars.
yeah, it also sounds like you got pretty good tabs on everything in your um, county, knowing where everything is. I guess structurally what structural. I can't even say the word structurally, in terms of longevity and how damaged it is, but what you can use for it in the future. Sort of asset management, I guess, is where I'm going with this.
I've been here 31 years, and yeah, you get to know them all. uh, that's just kind of the reality. My assistant truly does the bridge inspections and the bridge ratings, but I'm
Right.
still certified to do the bridge inspections. I won't claim I'm knowledgeable to do the rating.
But I mean, what I'm getting at is like a good asset management plan helps you
Yeah,
forecast for the future.
yeah, and there's no question. I'm looking at bridges and I'm thinking, boy, I'm going to have to get to that one in the next few years. And my Alex is my assistant. Alex said, "Oh, that one's good for a while. You don't have to relax on
Shout out to
that."
Alex.
He says, "But you know, you really need to be looking at these over here." Well, yeah, but that's not really fitting in my money flow as the way I want to.
uh,
That's what it kind of comes down to.
Terrific. Okay.
Hey,
Sorry,
actually,
go
Jerry,
ahead.
can I just jump in? Brian,
Yeah, yeah.
as part of the Low Volume Roads Conference that was held back in 2023, for those of us that stayed around the extra day, we got to tour a lot of these bridges. One of the ones that impressed me was something you had tried, which was the press brake tub girder.
Oh yes, and that was the first one too. That was the first press brake tub girder, and so even and it wasn't that expensive. It was a little more expensive than standard, but that one is a technology that really developed since then, since we built it. And there's a company called Valmont that actually put a plant in and is mass producing these press brake tubs. So what they do is they take 8 foot wide steel plate, typically. It could be, I suppose the size of the beam, and they fold it into a box shape, put shear studs on it, and that becomes your bridge beam. Rather than rolling steel, it's a plate steel that's formed, shaped. I've got numerous pictures of it, and yeah, I'll show them at their conference too.
All right. If you guys want to see that, better sign up for the Low Volume Roads workshop at goodroads.ca/education. Just put a little
When
plug there for that.
they're doing a lot of bridge bundling in some of the states, such as Pennsylvania and Michigan and such, and where they're trying to get a bunch of bridges out at a time of all basically the same design.
Hmm.
And they can typically beat the competitive bids on other designs. So it's definitely a technology that's developing. We talked about steel from the 1800s and such.
Yeah.
They didn't use any road salts back then. And so nowadays we better be thinking how we're going to do it. We're doing a lot of galvanizing, but there's also some other technologies out there that would possibly pertain to my rail cars if I ever got real concerned about it. And that is sacrificial anodes and such. So there are ways of doing things.
Yeah. Okay.
I did a bridge called the Buffalo Creek Bridge, and downstream from that bridge was a bridge that I built in the mid 90s. So now I've had to do repairs on the piling encasements. Now that's bad when you're starting to repair bridges or doing any kinds of repairs on a bridge you built yourself. That's either you're really getting old or you're getting better work on better designs. So again, we worked with the industry and we galvanized and coated the H piling. So I didn't have to do concrete encasements. Well, that was the fall of 2018. We had 3 50-year storms, floods events while we were trying to build this bridge. If I had to build
Wow.
cofferdams to do the concrete encasements on those piling, I never would have gotten that bridge done, or not till the following year.
Wow.
So what it ended up saving me about 6 months of road closure.
Nice.
And that would have been a devastating 6 months of closure too, because that was the spring we had all the frost boils.
Oh, wow. Okay. So we've talked a lot about bridges. Since we're going to be at the Low Volume Roads workshop, let's talk a little bit about low volume roads. How do you approach the maintenance and construction of a low volume road differently from like higher traffic roads?
Well, your low volume roads tend to be aggregates rather than
Okay.
pavements, and there are states like Wisconsin that can actually do have a lot of thin surfaces, but I can't have the thin surfaces with my soils.
Okay.
And that ties back into my comments just a couple minutes ago about frost boils. And a lot of people don't even know the science behind the frost boil. And what it is when you get these freezing temperatures, and you can say below zero for you guys or for us,
Yeah.
our soils, we have a lot of silts, and they'll set up capillary action. And it'll start pulling moisture up from the bottom and freezing into a frost lens. So this ground just keeps growing and growing and growing.
Oh,
And that's how we
okay.
get a frost heaving. And you've seen frost heaving. You can get 10, 12, 15 inches of frost heaving in places.
Right.
That's pure water down below your road surface. Now, if we thaw slow, there is a big heat source. We'll thaw from the bottom, and that moisture can get away. But if we thaw fast like we did in the spring of 2019, we'll have frozen ground down below with the zone of pure water underneath our road surface.
Oh, wow.
Oh, wow is the right word. I had a few others that came to mind, but that wasn't appropriate.
I'm thinking on a smaller scale, like potholes, but I'm sure you've seen roads completely collapse.
They'll turn to mud. Yeah. Yeah.
Yeah.
If you could keep the trucks off of it, you wouldn't have that problem. But we've gone away from the horses and buggies and we've gone to trucks.
Right. Right.
So the world keeps changing. And now you're going back to potholes. The secret there, well, there's several secrets, but you've got to have a crown. And that's a challenge in itself because the heavy loads will keep beating the crown flat. And a prime
Yeah.
example is and then what happens is you keep trying to pull it up and pull it up, and they beat the crown flat, and then you pull things up. Well, the road base will actually get wider, and your side
Yeah.
slopes, your ditches will get steeper.
Oh, wow. So you got another complication there.
Yeah. Well, and the real complication comes if you want to come back and grade it back into shape and maintain it like you're supposed to.
Yeah.
People don't like you taking this 32-foot top or 34-foot top and making it a 26 or 28-foot top again, which is easier to maintain.
Yeah.
Especially when the combine going down there's got, or tractors, whatever, sitting out there 22 feet wide.
Yeah. No, I can definitely imagine that. People get used to the wider roads and
Yeah.
all of a sudden you take it away. Is there anything you've seen out there that, I mean, probably not, but is there anything that can mitigate these bigger vehicles from pounding down the crown?
There's a lot of things going on, and we're going to use the term of base stabilization. How can I make my soil stronger?
Right.
And we're playing around with a lot of different products. Most of them are proprietary. And actually, there was one company that I was dealing with, and it's Jay Lemansky, and I'm trying to remember the name of the company is, but it's a Canadian-based company.
Huh.
And his answers to me is we use this on a lot of the roads going into our quarries as a way of
Okay.
strengthening the soils.
That's
And
interesting.
so, yeah, it's everybody, we keep talking and keep looking for better answers. Now we're back to the problem of volume and economics and everything. So there's numerous
So
products out there. I'm not sure which is going to work the best long term. The old adage is Portland cement stabilized or fly ash. But with the coal industry and the electrical generation being shifted away, we don't have the fly ash that we used to have available.
hey, Brian, I know one of your neighbors, I believe it's Johnson County, is using an instrumented vibratory roller to kind of assess the modulus of the roads to identify weak spots.
That's
Do you do the same thing?
Well, that technology is yeah, you saw it in Johnson County, but we're the first county to get it done here. Now they
Okay.
calibrated it in Hamilton County, I think, but yeah. Yeah, that was done this spring. And I think they're all done. They might even be in the county yet, but they are running virtually all of our rock roads to find the shear strength of our soils. Then I can go back in and start saying, now I got problems on this mile. Here's a zone I need to treat, and the rest of this I can leave alone. It's strong enough. And not only that, I can start evaluating the different methods of base stabilization that we've done and see how strong it actually is. And I'm going to give an example there. There was a product I used in 2019 that was a polymer. And when
Okay.
the guys were installing it, they said, Brian, it smells like Elmer's glue. It did. You know, the road surface was just beautiful. It looked like a pavement when they were done. The kids were going out there and leaving their rubber marks there burning out on my rock road, and the aggregate wouldn't pick up, but their tires would stay there.
Oh wow.
But it only lasted a few months and then it broke down. I'm assuming from the
Oh
sunlight. Now, how far down did it go? Well, I was looking at the results of the shear roller, and my soils are still real strong below it. So, hey, I was successful on strengthening the road base, so I shouldn't have the frost boils, but I still have a surface that's not loose aggregate and dust.
yeah. Well, you've got one problem solved. Just got to solve
One
the other one
stretch
then,
of
right?
road. Now we'll move on to the next. I've done a bunch of fabrics too. And I'm really
Uh,
the most optimistic on the fabric side of it, though the fabrics are not cheap in any way, shape, or form either.
mm,
Uh,
okay.
the one stretch I put that my guys did, and it could have probably done a little less expensive, but I had about 30,000 in a quarter mile. I can't afford to do that with 700 and some miles of roads.
Wow. Yeah. No, definitely not.
So yeah, that's the base stabilization and thin surfaces. One of the thin surfaces that looks real optimistic is what's known as an autoseal, and that's a technology that was developed in Norway.
Okay.
And I know that we went up to Minnesota and saw a project that was done about the year 2000 that looked really good yet. But the problem, and I know they've done some in South Dakota too. Now there's a bunch of counties doing it in Iowa, and I played around with several spots on it. And looks real often. I describe it as a chip seal on steroids. And it's
Oh
basically the
wow.
same thing as a chip seal, but the rolling effort, you have to roll it a lot more than you do a chip seal. Chip seal, you're just trying to get the rock embedded in there. The auto seal, my description is you're really trying to pull that oil up all the way through the rock.
Right. Right.
Yeah. Yeah, that was going to be my comment. That's almost kind of comparable to what we would consider like a high performance chip seal here that can be done in either kind of one or two lifts.
Yeah. Yeah, in the same way here. Now, the big difference is on the auto seal, I'm using a crushed road rock, and I push the limits a lot of times. So I'm not always the one that's doing it the right way. But I use some 1 inch aggregate. Now, in theory, if I use a 1 inch aggregate, I'm going to have an inch and a half surface when I'm done. Well, this is closer to 1 inch when I'm all done. But I was trying to get some strength in that base.
Wow. Cool.
So
Take the pressure off the base is probably a better description.
so with that process, Brian, how do you make that decision to go from, I guess, the gravel or rock road to the auto sealed road?
It goes back to public demand. In my case, what I've really started using it for is I've covered the auto seal over a concrete pavement, and that was in 2019, and I did it on some asphalt too as a chip as an economical way of resurfacing my asphalt,
Okay.
trying to preserve my asphalt better.
So
And
we got a little lesson about higher volume roads from low volume roads. I'm
um,
guessing it worked out well.
yeah, it has. I've got a little bit of base failure on one stretch that I put it on a rock road. And your question may have been, how do you know when to convert a paved road back to a rock road? And it's not a real question yet because where's the money going to come from? There
Yeah.
should be the issue because what I get allocated towards my paved roads is about half as much as I need to.
Oh wow.
And doesn't it always go back to money? So my argument back to the board. Here's an example. I'm spending close to 700,000 per mile on my roads when I do an overlay. I'm also putting
Wow.
a tide paved shoulder and putting a safety edge in, pouring the radiuses back. Um, when I get to side roads, so my blade operators aren't up the edge of against the edge of a paved road trying to pull material up. And like I said, I'm close to spending 700,000 a mile. I have 202 miles of payments, and I'm allocated 1.4 million a year. So I could get
Oh
to
my
them every
god.
100 years. Sort of like my bridges, isn't it?
Yeah. Wow. Yeah.
So the real issue is you're gonna have trying to find ways of making these payments last longer.
Yeah.
And people don't realize the damages from the heavier loads.
Right.
Um, I'm looking at a report, TR 781. It's a research study underway in Iowa right now, and I saw some of the preliminary numbers. And that's the Dr. Halil Jalan that's doing this work. And his preliminary numbers are basically saying it's costing for every super mile a super load travels over my roads, on my concrete roads, it's a little over $500 a mile of life it takes out of that road.
Wow.
And super load, they're looking at about 125,000 pounds. Well, the real question goes back to what's going on in Iowa, where they just went from an 80,000 pound load to where the state will issue permits for 90,000 pound loads. And how much faster are roads going to deteriorate?
Yeah. Wow. Do they don't, I guess they don't, for issuing those uh permits, that you guys don't see any money from that, do you?
We will. We do and we will, but as nowhere does it begin to cover the cost of the
Yeah.
damages.
Yeah.
And that's kind of the issues going on. So we had a legislator making the comment that why the counties have been building these roads heavy enough for the heavier trucks since the 1970s.
Oh my god.
In the 1970s, bias ply tires were common, and 70 psi pounds per square inch truck tire pressures were common.
Yeah.
Nowadays, 115 psi is common in the truck tires. And Dr. Chris Williams was communicating with him a while back. He says, Brian, going from 70 psi to 115 amounts to a 443% increase in the damages on your road system.
Wow. So this is something where the legislators have to get in line a little bit and realize that they've got to stop.
There's got to be an education process, and maybe if we
Yeah.
could send them back to that one room country schoolhouse with 8 grades in one room, we could teach them something.
All right.
It's got to
Um
be an education process.
yeah, yeah.
Jared, I should also point out, Brian had mentioned Halil at Iowa State. He's also coming to speak at our Low Volume Roads conference, kind of about
Fantastic.
that topic. And also, they're in the process right now of developing a granular road structural design tool, kind of looking at that whole asset management life cycle, which is going to
Terrific.
be rather informative too.
That's fantastic. Okay. Um all right, I really want to be cognizant of time too. So I have one more question. James, do you have anything you want to add or ask?
Kind of road wise, but kind of moving away from the road. There was something I also saw while on the tour. You were slip lining or kind of coating, I guess, the inside of your culverts. The one that we saw was already out. It was new. It was going to be placed in the ground. But I believe you've also kind of coated other buried pipe to increase your Q factor and I guess that flow rate to the.
What we're really doing is repairs on them.
Okay.
And yes, we've done this. I've done this a bunch with different types of materials. And there's actually one right now where they blow a liner in there, then inflate it, and then they harden it with ultraviolet lights. Now, I haven't used that one because price always dictates. And I've done a bunch with high density ethylene HDPE, and the pipes would literally snap together, and then you'd push them in, and you'd grout the rounds around them. And basically, what we're doing there is screwing in some liners, and then they pump grout around it, tighten it up.
Hmm.
And they can, you mentioned, because your in factor is so much better, you can actually get more water through that. A lot of times where it governs is inlet capacity governs on an awful lot of this when you get into the hydraulics of it. So yes, you can improve your flows, but you're doing repairs. If you start cutting the pavement and trying to repair a pipe underneath the pavements, that becomes a real issue. You got a lot of settlement issues over time.
Yeah. Okay. All right. One last question before we let you go. What do you see as the biggest future challenges for infrastructure in rural counties like Buchanan?
The real issue is having the funds to do the job. And so you'll never have enough funds to do the job. So we've got to come up with better ways of doing things better and longer. And that goes back to the amount of traffic and the amount of heavy loads we're getting on our road system.
Right.
You would think of logging roads and such as getting a lot of weight. Boy, these agricultural loads are too.
Yeah. Yeah.
In this part of Iowa, there's an expression, if they build it, they will come, referring to the field of dreams.
Yeah. Yep.
Well, Balzer's now making a 2,850 bushel grain cart,
Oh, wow.
and that's on 3 axles. Now, they're not supposed to run them load down the roads, but what happens when they move from one field to the next?
Right. Exactly. Well, they better be empty, hopefully.
Hopefully. If we build it, they will come.
Yeah. All right. Well, yeah. So we're looking forward to having you at the Low Volume Roads Conference in October. In about 5 minutes, is there anything you want to leave people with before they come to this conference?
No, it's just, hey, as we go out there, we all have our challenges, and it's how we handle them and how we address them. And there's never enough money to do it, so you got to do it the best you can for the most economical way.
Yeah, it's always about money, but something that's not going to be a bad investment is registering for this Low Volume Roads Conference. Everybody in Ontario has low volume roads. There are probably very, very few municipalities that don't have low volume roads, so a lot more people should be signing up for this. We've got great speakers like Brian coming. This is just one. We've just been talking to Brian for the last 52 minutes, and he's dropped a ton of great information. So you're going to want to be there to listen to everybody, get all the information on your low volume roads and how they work. Brian, thanks again for joining us. We look forward to having you at the conference in Barrie in October. James, thanks for filling in for Mr. Thomas today.
My pleasure.
Everybody else, be sure to follow us on Twitter, Facebook, LinkedIn, and Instagram for up-to-date information on everything happening at Good Roads. Education courses are starting up throughout the fall at goodroads.ca/education. If you're watching this on YouTube, give this video a thumbs up and remember to subscribe, because it's not just the podcast that goes up here. We offer tons of great content to help you run your municipality as efficiently as possible. And hit the subscribe button. I've seen a lot of people who aren't subscribed. You got to get those notifications, hit that bell. Leave a comment. If you have any questions for Brian, send it through to either myself, podcast@goodroads.ca, or leave a comment in the YouTube video and we'll pass that along to Brian. Maybe he can send you a response, or you can come to the Low Volume Roads conference and have that answered personally. So once again, thanks everybody for being here. And until the next episode, take it easy.